Okay, so I'm going to do a power test. This is rated for 70 watts per channel. So that should give us 23.6 volts average. And I'm going to crank this up to that voltage. Okay, I have to turn up the input amplitude. Input. There we go. Looks like it's going to be putting out more than 70 watts. Both channels. Oh yeah. Nope, close. So that's for the meters. This one's peaked on the left channel. So that's good. That's indicating clipping perfectly, and actually, yeah, these needles do seem to be showing the maximum at 70 watts, so that's calibrated nicely. This one is pushed a little bit past. Bring it back a little bit. So what did I calculate again? 23.6 volts. This is at past 25 volts. But it looks nice and round. There doesn't seem to be clipping, although it is sending a clipping signal to the left channel. And just to do the math here, 25 squared in 8 ohms. That's about 78 watts of power. Let's take a look at the distortion. So let's start with, just double check these traces individually. So that's yellow. That's red. In fact, while it's up here, let me check the other frequencies. Let's go to 20. Okay, it's starting to warm up, but it's not getting too hot. See that the voltage dropped a little bit. And let's check the other channel. Looks clean. Symmetrical in power output to the other channel. Let's again look at the, let's go down to 20 hertz. And you can see it's just barely activating the peak indication at that level. But it's definitely pushing this amplifier just past the max. And it's not the most beautiful signal here, as we can see. Oh, maybe if it gets triggered properly. No, it's not responding great at this point. Okay, let's see, let me just adjust this properly. There we go. Way here, there we go. There we go. So as you go down in frequency, it's just pushing out a little bit more power. Okay, so like I was saying, let's check the performance here. Let's go back to 1 kilohertz. Okay, so that's really clean. That's the 1 kilohertz fundamental frequency. That's the first even harmonic being dominated by the next odd harmonic. And it looks like about a similar distortion pattern throughout the frequency spectrum. So it's saying that with the power being put out at over 70 watts, with 1 kilohertz being put in, this much of that signal is at 1 kilohertz, and everything else showing up is distortion. This is a decibel scale where 1, 2, 3, 4, 5, 6, almost 7 squares represents 7 orders of magnitude relative to the other ones. So 7, that's a 10 millionth ratio. If you take away, let's call this 2, 5, that's 100,000 times difference that you would hear 1 kilohertz versus 2 kilohertz, or 3, 4, 5, so on and so forth. And even less of the frequencies that are in between, intermodulation, distortion, if I'm getting that term right, or interharmonic distortion. Okay, let me check the other channel. That's channel 2, this is channel 1, which would be left, and it's showing a very similar distortion pattern, actually slightly lower even harmonics. And just for fun, I'll bring this back down and we'll see what it looks like. So again, that's 1 kilohertz, and there's a slightly higher ratio to distortion from the input frequency. 1, 2, 3, 4, but still about 10,000 times less audible, or not audible, but significant. Okay, and again, just the other channel. Showing about the same thing. So just while I have this opened, it looks like it's all original. It has matching Fairchild transistors on both sides. And it looks like all the parts are all original.